and welcome once again to this series, The Final Three. This is November 2017. This is paper 2, so you can use a calculator on this one. If you're new to the channel, please do leave a like and subscribe. I'd really appreciate that a lot. And there'll be a comment section below if you want to make comments on this particular video or steer me to things that you want me to do in the future, and that would be really helpful to help build the channel up. If you're revising for your exams in the summer and you're new to this channel is just literally for anybody who's already done all the content and is just preparing for their summer exams. I do wish you all the best of luck with it. I'm sure you've done a lot of hard work already. This particular series, just the final 3 questions in all the exam papers since June 2017. And as I mentioned earlier, this is November 2017. So this is question 21. You can see already set up and ready to go. It's a probability question. It's talking about 12 counters in a bag, equal numbers of red counters, blue counters and yellow counters. So what we're doing here is we're thinking, well, if it's 12 things and there are even numbers of or equal numbers of red, blue and yellow, there must be 4 of each. So 4 of those, 4 of those and 4 of those. It's asking for 3 counters to be taken at random from the bag. You're assuming they're not replacing them. Work out the probability of taking 3 red counters. So because there's 4 to start with, that'll be 4 out of 12. Then you've got 3 out of 11. And then you've got 2 out of 10 finally to go through 3 counters. As I mentioned earlier, this is the calculator exam. So you can simply just throw those numbers into a calculator and you'll very quickly get 1 out of 55. No problem at all. It then says the 3 counters are put back into the bag. Some more counters are now put into the bag, and there is still an equal number of red counters, blue counters and yellow counters in the bag. There are no counters of any other colour in the bag. 3 counters are taken at random. Is it now less likely or equally likely or more likely that the 3 counters will now be red? Well, let's just model that. So we started with 4 of each, so 4 red, 4 blue, 4 yellow. Let's imagine now that we have 5 red, 5 blue, 5 yellow. If that's the case, we had 15 in the bag. And to get red 3 times in a row this time would be 5 out of 15, and then 4 out of 14, and then 3 out of 13. So you've got to multiply all those possibilities together. If you do that really quick, you will find that you'll get 2 out of 91. Now, to compare and contrast 2 out of 91 with the value we had earlier, the 1 out of 55, you're going to just need to press the SD button on your calculator. So that's to be found, I'll just show you, that's to be found here. So here's 2 out of 91, and this is the SD button here. So SD, it's a little bit foggy on the calculator, I hope you can see that. So if you press the equal sign and then press SD, it'll give you the decimal, and you can see that there. So 0.0219, okay, roughly. So 0.22, roughly, approximately 0.22. Now 1 over 55, in the same way we can write that as a decimal, so that's 0.018 as a decimal, so 0.02. So this is less than the number we just saw. So this is slightly more chance because it's a slightly higher number. And so because 2 over 91 is more than 1 over 55, the chances are greater, more likely. So more likely. And just make sure that you've understood that this is with 5. If we did it with 6, the same thing would happen. You get a slightly bigger number again. If you did it with 7, slightly bigger number again. Okay, because we've just done a random number, I know it's going to happen every single time. So you do 6 out of 18 or 7 out of 21, for example, you'll get the same thing happening. It'll be greater every time. Right, question 22 we're moving on to. And that question is a functions question. So here it is. And this is a functions question that leads quite quickly into a simultaneous equation question. So it's quite an interesting question from that point of view, testing lots of areas within the syllabus. So the first thing it says is to try out G3. So the function 3 put into this bit here. So let's try and write an expression for that. So G3, and we're going to put an x being 3 here, so 3a plus b. And we're told it's 20 in the particular question, so that's 20. So 3a plus b is 20. I'm going to call that equation 1. Okay, we'll need that in a minute. The next bit it tells you is that the inverse function of 33, inverse f 33, is the same as g of 1. So we need to find this inverse function. So let's do that. To find an inverse function, you let y be the function to start with. So y equals 5x plus 3, and then rewrite it so that x is the subject to the formula. You'll get that relatively quickly. It's y minus 3 over 5. And then that must mean that the inverse function, the f to the minus 1 of x, is x minus 3 over 5. Okay, so just switching through all those things. This should be something you've done as part of your standard revision. I may have done a video on functions. If I have, it probably will be on the channel there. Take a look if you're not aware of what to do. So x minus 3 over 5 is what we've got here as the inverse function. We're told that it's inverse function of 33, so we need to find out what happens when I make 33 my x value here. So if I did 33 minus 3 over 5, I'm going to get 6. So they're telling me that's g of 1. So earlier on we met g, here it is. So g of 1 here will be 1a plus b. So I'm being told that 1a plus b is 6 because those two things have to match. So g of 1, a plus b is 6. That I'm going to call equation 2. So I've got two equations now, equation 1 from earlier and equation 2 from here. You can see this is a simultaneous equation question with the b's being the same. So I'm then going to construct an elimination problem here. So 3a plus b equals 20, and then a plus b equals 6. These are the two equations that I wrote side by side, and I'm going to subtract them. So 20 take away 6 is 14, b take away b is gone, it's eliminated, and 3a minus a is 2a. So 2a equals 14, and that must mean that a is 7. Okay, and if you do some substitution and substitute that back in for b, well, if a is 7, b must be minus 1, and you'll get that really quickly from either of the formulas that you used earlier on. So a is 7, b is minus 1, and again, a nice 5 marks. The last question we're going to do is on geometric sequences. So there are three different types of sequence that you've got to know. Arithmetic sequences with a common difference, geometric sequences with a common ratio, and Fibonacci sequences. This is a geometric sequence. We're looking for a common ratio. And that means that this divided by 1 is the same thing as 1 divided by that. So we can write that as an expression. Let's just write that. So root x plus 1 divided by 1 is the same thing as 1 divided by root x minus 1. And you can see this is the equation we're going to have to solve. So if I multiply both sides out and do some cross multiplying, you'll see quite quickly that what I'm going to do is I'm going to end up with this problem here. So these two things, this one here multiplied by that one there. So I'm going to get root x times root x, that's x. The middle terms will cancel. I'm left with minus 1. And so x is 2. Okay, 1 plus 1 is 2. That gives me my x value really quickly. So that's the 3 marks to start with. The last bit says, show that the fifth term of s is 7 plus 5 root 2. Well, if x is 2, then I know that this is 1. My next term is root 2 plus 1. So 1 root 2 plus 1. So my first term was root 2 minus 1. Just get that back here, root 2 minus 1. So the sequence is going root 2 minus 1, 1, root 2 plus 1. So you can see the common ratio here, the number I'm multiplying by each time is root 2 plus 1. That's what I'm multiplying by each time. So I've got to multiply this by root 2 plus 1 again. So to get the fourth term, 1, 2, 3, fourth term. So the fourth term will be root 2 plus 1 times root 2 plus 1. So again, if you multiply those two things up, you're going to get 2 plus 2 root 2. And then plus 1 on the end. So that's 3 plus 2 root 2. Lastly, we're going to have to do, that's the term we get for the fourth term. To get the fifth term, I have to multiply this by root 2 plus 1 again. So 3 plus 2 root 2 times root 2 plus 1 again. And that's going to be 3 root 2 there. And then we're going to have times by 3 there. So 3 lots of 1. And then 2 root 2 times root 2. So root 2 times root 2 is 2. And 2 2s are 4. And then 2 root 2 times that. So we're going to have that there. And that's going to be 5 root 2. So 3 plus 2 root 2 plus the 7 there. And you can see that's the same thing as what the question was asking you to get. So 7 plus 5 root 2 is written back to front. But you saw me get that. And that is your extra 2 marks for your 5 marks got. Okay. That's the last question. This was November 2017, paper 2. I wish you all the best if you're revising for your summer exams. Keep checking back the channel. I'll keep adding these in the next few days and weeks before your exams are due. Good luck. I hope to speak to you soon. Bye-bye.